So now I'm going to do a few more examples with the quadratic formula. If you were in class, I would have you memorize this. You should know that x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, so we're going to apply that to a few more problems. First one is going to be this. So I'm looking at this and I'm going to try and see if I can factor it in my head real quick. And I'm saying 2 times negative 5 is negative 10. Are there two numbers that multiply to negative 10 and add to negative 2? No, I don't think there are. So rather than puzzle through that a little bit more, I'm just going to go ahead and use the quadratic formula. I'm going to list my values for a, b, and c. Remember, a is the number in front of x squared, it's 2. B is the number in front of x, which is negative 2. And c is the constant at the end, which is negative 5. And I'm going to apply that to this quadratic formula. So I'm going to say x equals the opposite of b, which is 2, plus or minus the square root b squared, which is 4, minus 4 times 2 times negative 5 all over 2 times the a value, which is 2. So it's a mess, but we're going to clean it up. So I've got 2, we'll say x equals 2 plus or minus the square root of 4 minus parentheses 4 times 2 times negative 5. 4 times 2 is 8. So this ends up being negative 40. All over 2 times 2, which is 4. I'm going to clean up that square root even more. 2 plus or minus the square root. Minus a negative means plus, right? So we have 4 minus a negative 40. That means I'm going to add those two numbers, which is 44. All over 4. Now this is getting close to cleaned up, but this 44 right here, that can be simplified further. There's a perfect square in there. So either you can just look at it and see. If you're a factor tree kind of person, we'll say 44 can be separated into 4 times 11, and 4 is 2 times 2. So there is a perfect square hidden in there. That 2 will come out, and the 11 will stay in. So 2 plus or minus 2 root 11 over 4. Now we're going to examine these these outside numbers here, and we're going to say, hey, 2, 2, and 4 all share a common factor, and that common factor is 2. So we're going to divide each of them by 2. And then I have 1 plus or minus 1 root 11 over 2. That's my final answer. If you really wanted to clean it up, that 1 in front of the root 11 is not necessary. So the cleanest version of this would be 1 plus or minus the square root of 11 over 2. And this represents your two roots. This is what x equals. These are your two square roots. If it contains a radical that cannot be simplified, then you know that this was not factorable to begin with. You would have never found factors that worked there. Okay? Let's look at one more example. If I have 5x squared plus 8x minus 4, again, I can try factoring it, and that might work, but I'm going to go ahead and apply the quadratic formula. So I'm going to say a equals 5, b equals 8, and c equals negative 4. And I'm going to set up my formula. X equals the opposite of b, which is negative 8, plus or minus the square root of b squared, which is 64, minus, put a parentheses in there because you don't want to mess up your signs, 4 times a times c, all over 2 times a, 2 times 5. I'm going to clean everything up. So I have x equals negative 8 plus or minus the square root of 64 minus 4 times 5 times negative 4 is negative 80 all over 10. 2 times 5 is 10. And clean that up a little bit more. X equals negative 8 plus or minus 64 minus a negative 80 is a positive 144 all over 10. Well, this is exciting. 144 has a perfect square, so we're going to go ahead and take it. And the square root of 144 is 12, so I have negative 8 plus or minus 12 over 10. This gives me two solutions, and it's very easy to clean this up further, so I'm going to go ahead and do that. I'm going to have two numbers here. The first one is negative 8 plus 12 divided by 10. Negative 8 plus 12 is 4 over 10, which simplifies to 2/5. And then my second solution is negative 8 minus 12 over 10, which is negative 20 over 10, which is negative 2. So my two solutions to this equation are 2/5 and negative 2. And because these are both rational numbers, rational roots, 2/5 and negative 2, you know that this could have been factored. So you could have solved it by factoring, but you could also solve it by the quadratic formula. And as we get more practice with this, you'll start to discern which one is best for you.